Hello, I welcome you to the next tutorial for microwave testing. This is a method for non-destructively testing of parts made from glass fiber reinforced plastic and other non-conducting material. If you want to learn how this method works, then you are right here. In earlier videos, we have already used this handheld transmit and receive test head. Today we will look to it more closely and to the display which can be used with it. This here is the microwave antenna. It is an open-ended metallic rectangular pipe with a planar flange. Through this opening, the wave is transmitted, and through this opening, also the reflected wave is received. The receiver inside detects the signal such that the output are two voltages, one for the horizontal deflection and one for the vertical deflection. There is access to these two voltages over this USB port on the rear side of the FMH4. Through this USB port, also the power supply of 5 volt, the standard USB voltage, is supplied. In the following, we will see how a laptop can be used to display the signals from this test head. At the end of the video, I will mention also other possibilities for the display. Here is the test head connected to a very flexible USB cable. This cable is connected to a split box to separate the port for the supply voltage and the two signals ports, horizontal and vertical. The supply voltage is delivered by one USB port of the laptop, and the two signals are also fed over another USB port into the laptop, but via an adapter which allows the laptop to be operated as an oscilloscope. In this configuration, I would have to operate the system by the touchpad, and I have no possibilities to connect a wireless mouse. Therefore, I have changed it a little bit in the following manner. Here we have the system with the one port now connected to a module for the wireless mouse, and the other port with a splitter cable for two USB ports. With the laptop being operated by battery, we have here a microwave test system, which is free from mains connections and therefore rather flexible, movable. The laptop is now switched on, and it is switched into the XY mode. We see the characteristic materials point. When we place it now on the test part, which is the section of GRP leaf spring again. A sliding of the test head over the surface gives a characteristic signal, a hook with spirals, and I go back. This is originated from a hidden defect. We can also go to the storage mode and repeat this. Then we get this indication stored on the screen, and we can also store it on the computer. That is this way. So we have it ready for documentation or other purposes. The hidden defect, not to be seen from the top side, but to be seen from the back side, is a blind hole into the back wall of the GRP section. By the way, what we saw in the display is called the reflection coefficient, and it is drawn in the plane of the reflection coefficient. So far, the handheld device with the display is a laptop. Further display options are, for example, a true oscilloscope and also an eddy current test system using an appropriate adapter. The handheld system normally is guided by hand, but it can also be used in an automatic scanning system, and it can be used in a robotic system, similar to that which we have seen in the application video for the testing of radomes. In the next tutorial video, we will see how the handheld system is operated on planar surfaces of further components. And in the following videos, we will see the handheld system being operated on curved surfaces using special adapters. So far for today. Thank you for watching. See you next time. Goodbye.